All right, here we go. Geometry, first e-learning day. Who's excited? I couldn't hear anybody say they were excited. Oh, wait, that's because none of us are all in the same place together. I bet you were all saying you're very excited because I'm very excited. All right, so right at the top of the notes, you will see sample space. This is a new vocabulary word. We need to put this vocab term down. Sample space of an experiment. Now, experiment is a broad term here. Experiment doesn't just mean those things you do in chemistry and biology. Experiment here is anything that has a probability associated with it. Like, what's the chance that you're going to flip a coin and it lands heads? That's an experiment if you flip that coin. Or if you roll two dice, what's the chance you're going to get a 7? That's an experiment rolling those two dice. So the sample space of one of these experiments is the set of all possible outcomes for that experiment. So make sure you've got that written down, that first box right on your notes. If you don't have your notes, go to the Canvas page. I uploaded them right there in case you were sick, in case you lost your notes, so you can download them and print them off. You got to have the notes in front of you in order to fill them out. Sample space, set of all possible outcomes. List all the different things that can happen for a given experiment. That's what the sample space is. All right, let's go on. So in an experiment, 3 coins are flipped. Let's list all the possible outcomes in the sample space of this experiment. Now this picture here, this is one of the possible outcomes. So this is, the first coin got flipped, it's a heads, boom. The second coin got flipped, it's a heads. The third coin got flipped, it's a tails. So instead of writing that all out, or you having to draw a million pictures of Abraham Lincoln and the Lincoln Memorial, we can just abbreviate. So this one, I would abbreviate as follows. HHT for heads, heads, tails. Now, this is different. HTH. This would stand for heads on the first flip, tails on the second flip, heads on the third flip. So the order is important. Each different thing that can happen, even though both of these have 2 heads and 1 tails, it doesn't matter. They are different. If there is some difference between two outcomes, then you have to list both of them. So if you want to try this on your own, go ahead, pause the video, see if you can list all the possible outcomes. If you are still a little bit confused, you want to go through it with me, then go ahead and just keep letting it play and we'll go through it. All right, we've got all the possible outcomes. We could go heads, 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 tails, heads, tail, heads, tails, heads, heads. Basically any combination possible of heads and tails. And we got to make sure we didn't double up anywhere. We got to make sure that we've got all the possible orders. So you just got to be very careful when you're going through it. Find a systematic way to write them down so you can make sure you have all of them. You didn't accidentally write any of them twice. But these are all the possible outcomes that could happen if you flipped a coin 3 times. Or you flipped 3 coins, I guess is better, because we have a picture here of 3 coins. All right, let's keep going on here. All right, we got a spinner over here. In a new experiment, we spin this spinner. Look at the spinner. You should recognize there's a lot of slices on the spinner. There's 1, 2, 3, 4, 5, 6, 12 slices on this spinner, but there are not numbers 1 through 12. It's just numbers 1 through 5. Some of the numbers are repeated. How many ways can you spin a 1? Well, how many ways can you spin a 2? How many ways can you spin a 4? So is there more than one way you could get a 1? Well, no, it's just if you get in this section right here. That's the only way to get a 1. But what about getting a 2? Okay, I could get here, or I could land here. Either one of those would be a way to spin a 2 if my spinner landed on either of those sections. So go ahead and pause the video, or if you're still confused, just follow along with me as we list out the ways we could spin each one. For a 1, we said right here there's only one way. I only see one little slice that's a 1. For a 2, there are 2 ways. For a 3, I see 3 different slices that are a 3. So 3 ways for that. For a 4, there's 2 different ways we could get a 4, and for a 5, well, there's 4 different ways we could get a 5. Okay, now listing the sample space. This is where you might be a little confused, because what are the numbers you could spin here? If I just listed out the numbers that I could spin, think about that. How many different numbers could you get if you spun the spinner? Well, only 5, right? Because I could get 1, 2, 3, 4, or 5. But every different outcome has to be listed. So spinning this 2 right here is different from spinning this 2. It's a different outcome. Even though it's the same number, since it is different, like it happens in a different way, we have to list each of them in our sample space. So if I go back a page real quick, just like this right here, 2 heads and a tail. That is different from this right here, 2 heads and 1 tail. They are different because in this case you can tell because the order that you got them was different. In this case you can tell that the green 2 and the blue 2 are different because you would have to land on a different spot of the spinner. So in order to list out the sample space, I've got to list out basically all the possible slices on the spinner. So I could get the 1 1, 2 2s, 3 3s, 2 4s, and 4 5s. So I hope you see the connection between part B here, the sample space, and part A, how many different ways you could spin a 1, 2, 3, 4, or 5. Now, part C says, what is the total number of outcomes? The outcomes are all the different things in the sample space. So to say the total number of outcomes, all you got to do is count the number of things in the sample space. So if we count the number of things, I think my answer might be wrong here. 10? I think that's wrong. Is that wrong? 4 ways here, 6 plus 5. Did I count my spinner wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I messed something up. Let's go back and figure out what Mr. Crouch messed up. There's 1 1, that's good. There's 2 2s, that's good. There are 1, 2, 3, 3 3s, that's good. There are 2 4s, that's good. And there are 4 5s. So how's there only 10 when I count 12 slices? Sometimes the answer must be right in front of you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I guess I just don't know how to add. That is 12 outcomes. Silly me. Hopefully you've had a good laugh at Mr. Crouch's lack of counting. I guess you don't need to count in order to be a teacher, even a math teacher. That's great. But we figured it out. We fixed it. It's a really good example, actually, of something that's super important. It's okay to make mistakes. I'm okay with the fact that I made a mistake. That's why I'm still using this video. I didn't start over and re-record it. It's okay to make mistakes, especially if you're cool enough to be able to figure out your own mistake, to be able to problem solve and go back and be like, I know I made a mistake. Something's not lining up. Let me figure out where it is. All right, let's go on. We got some definitions to write down. A probability experiment. That's the first one there. It's an action or trial that has varying results. An action or a trial that has varying results. So when you flip a coin, sometimes you get heads, sometimes you get tails. When you spin a spinner, sometimes you get a 6, sometimes you get a 3. When you roll a die, sometimes you get a 5, sometimes you get snake eyes. Who knows? So a probability experiment, action or trial that has varying results. Okay, the possible results there, all of those results are what's called outcomes. So the possible results of a probability experiment, looks kind of like I crossed it out, but I wasn't crossing it out. I was just doing a bad job of underlining. The possible results are the outcomes. So in the probability experiment of flipping a coin, the 2 outcomes are heads or tails. All right, let's go on. So for instance, when you roll a 6-sided die, there are 6 possible outcomes, 1, 2, 3, and 4. Awesome, that's pretty much what I said, but it's with a die instead of a coin. All right, a collection of 1 or more outcomes is an event. So sometimes when we talk about a probability experiment, we want to know about bigger picture things happening. So say you roll 2 dice two six-sided dice. Maybe I want to know how often are you going to roll 10 or higher? How often is your roll going to be even? How often is your roll going to be odd? Say I ask you to flip 2 or 3 coins, and I say, how often are you going to get exactly 50% heads? How often are you going to get more heads than tails? So these are called events when we look at a collection of one or more outcomes is an event. And what I want you to do actually is go ahead and pause the video or go ahead and jump back to those examples I just gave and write down a couple of those examples of events. The ones about rolling 2 dice, the ones about flipping a couple coins, etc. All right, let's move on now that you've went back and got some examples of events. Example 1, you flip a coin and then you roll a 6-sided dice. How many possible outcomes in the sample space? We got to list the possible outcomes. Now this is like a 2-step probability experiment here because you're doing 2 things. First, you're flipping a coin. How many things can happen there? Heads or tails? That's 2 things. Then you're rolling a 6-sided dice. How many things can happen there? 1, 2, 3, 4, 5, 6. So 2 things when you flip a coin, 6 things when you roll a dice. Think the answer is 8? Nope. Actually, the answer is 12. It's 12 outcomes? How does that make sense if I could only get 2 the first time and then 6 the second time? Let's look at it. Let's look at it here. We can use a tree diagram to help us organize the outcomes. So definitely you want to get this down. You really want to get this down right here. The tree diagram is the best organizational tool when you're looking at a sample space or the outcomes from an event, especially when you have multiple things going on. So notice here, I've got my first event, coin flip. Got the 2 possible things that can happen. Got heads here and tails. And then from each of those, I've got the 6 things I could roll on the dice. So this means that I could do, for instance, I could flip heads first. So I'd be going down that branch of the tree. And then I could roll a 5. That's one of the things that could happen in this probability experiment. I could roll tails. I could roll tails. That doesn't even make sense. I could flip tails on the coin and then roll a 5. So those are 2 separate outcomes. So with this tree, I can see all of my outcomes. I can see that I could go heads first down this branch, and then 6 different things could happen. Or I could go tails first, and then 6 different things could happen. So from this tree, I can see pretty clearly that there are 12 possible outcomes. Heads, and then 1 through 6, and tails, and then 1 through 6. If you want to abbreviate these like H1, H2, H3, H4, and T1, T2, and so on, that would be fine. But you definitely want to get those 12 listed. All right, let's go on. Awesome. In the next section, I want you to try this. Now that you've seen a probability experiment and you've seen how you can make a tree diagram for it and then list all the outcomes, try this with number 1 and 2. I did not leave you enough space to do number 2 on your paper. Hopefully you can either squeeze it in there, or even better, if you do it on a separate piece of paper, because you're going to need a big tree for that one. So go ahead, pause the video now, see if you can do these 2 problems, and then when you come back, let's go through them together. All right, now we're back. Time to go through these. If you flip 2 coins, we could get 4 different outcomes. Heads, 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 tails, tails, heads, tails, tails. All of those are different. The order does matter. If you flip 2 coins, then roll a 6-sided dice, you could get 24 outcomes. And I'm going to sort of sketch this one out for you, how you would make a tree for this. In case you got a little stuck, because this tree's big. So that right there's your first flip. You either get heads or tails. Then what do you do next? You flip another coin. So we could get, what could we get? We could have got, if we got heads first, we could still get heads or tails there the second time. Here we could still get heads or tails. So let me add some labels here. This is the first flip right here across this line is what you get, heads or tails. Then after that, our second flip, we still could have gotten heads or tails, but we've got to put it off of each previous branch. So off of this heads, I could either get heads or tails on the second flip. Off of this tails, I could either get heads or tails on the second flip. Let's go on. We got one more thing. Off of each of those, I could get 1, 2, 3, 4, 5, or 6. 1, 2, 3, 4, 5, 6. Same thing here. Here. Off of all of those, when I roll the die, I could get 1 through 6. So I've got to put all of those as separate possibilities, as separate branches coming off of the previous one. And using that tree now, I can get my different outcomes. I can get heads, heads, 1. Heads, heads, 2. Heads, heads, 3. So on and so forth. I can get tails, heads, 1. Tails, heads, 2, 3, 4, 5, 6. If I organize myself very clearly, like in this diagram, I can easily get all of my different outcomes listed here, and then make sure I have them all, make sure I didn't double any up, make sure I have the right count. All right, let's keep going. Got some more notes. Probability of an event is a measure of the likelihood or the chance that an event will occur. Need to get that down. I even realigned my smartboard right before I did this video. You can see how much it helped. My lines are perfectly straight. So need to get that down. Make that a bullet point right under probability of an event, because we're going to write down a few things. Now, we also need to get down the probability is a number from 0 to 1. Make another bullet point and include that. Include the including 0 and 1. Probability is a number from 0 to 1. So you can say the probability is 0.75. You can say the probability is 1. You can say the probability is 0. You cannot say the probability is 20. You cannot say the probability is -10. You cannot say the probability is 100. So probability, number from 0 to 1. And it can be expressed as a decimal fraction or percent. Can be expressed as a decimal fraction or percent. Put that as another bullet point. So you should have 3 bullet points there under, what are we on? Probability of an event. So as you can see right here, this is how you would write 1/4 or 0.25 or 25%. All of those are ways to say the same thing. I'm going to pause the video real quick. All right, picking back right up where we were. Sorry about that. All of these right here, beside the blue, are different ways to say a probability of 0.25, or a probability of 1/4, or a probability of 25%. You can say that, 25%. You cannot say a probability of 25. All right. So our probabilities range from down here being impossible. If you say something has a probability of 0, then it's impossible that it's going to happen. Because 0%, never going to happen. All the way up to something being 100% certain to happen. 100%, a probability of 1. All right, let's go on. More notes. The outcomes for a specified event are called favorable outcomes. Like I said, perfectly aligned board. Favorable outcomes. That's the outcomes for a specified event. So if you want to know how often am I going to roll a 5 or higher when I roll a single die, that would be those 5s and higher. Those are your favorable outcomes. If you roll a 5, that's a favorable outcome. If you roll a 6, that's a favorable outcome. If you roll a 4, no, that's not a favorable outcome. So when you specify an event, so each problem, you're going to have to know what the problem's talking about in order to know what the favorable outcomes are. So when all outcomes are equally likely, so pretty much everything we're doing right now will assume that all of our outcomes are equally likely. Then the theoretical probability, that's the, in theory, the probability of something happening, can be found with this following formula. So make sure you write down this formula right here. Theoretical probability, we take the number of favorable outcomes divided by the number of total outcomes. And then the probability of an event A, it has some notation. It's written as P of A. This is sort of like F of X. It's not F times X. It's not P times A. It's P of A. If you want to write that right beside your notes, P of A. That's what that means right there. All right, let's go on to an example, see how we can use this. All right, student taking a quiz randomly guesses on the answers to 4 true-false questions. This must not be about any of you. I know none of you would ever randomly guess on a quiz because you would all study and you would know it so well you wouldn't have to guess. What is the probability of the student guessing exactly 2 correct answers? Okay, so if I look back real quick, I'm going to flip back. I need to know the number of favorable outcomes. And favorable outcomes in here goes with the situation, not with favorable outcome for the student would be getting 100%. But look at what it says. Guessing exactly 2 correct answers. So anytime the student guesses exactly 2 correct answers, that's a favorable outcome right now, because that's what we want to know about. That's the event that we've specified. We've specified the event is that we want to know how often is this student going to get just 2 right. And so I need to figure out how many times is that going to happen and what are the total number of outcomes. So I need to get my whole sample space written out of all the possible things that can happen and then figure out which of those are favorable. All right, so let's look at how that goes. So to simplify things here, we could order our sample space in a chart. I'll show you afterwards how we can do it in a tree as well. But we could order it in a chart, and we could use a C for correct and an I for incorrect. And then if I think there's 4 questions, we're talking about 4 questions, I can put all the ways someone could get 0 correct here. I, 4 incorrect. I could put all the ways someone could get 1 correct here. Correct on the first, incorrect on the next 3. Correct on the second, but incorrect on 1, 3, and 4. Correct on the third, so on and so forth. So I could order all of my outcomes here in this chart so I can see them. And then this row here is all the ones that have exactly 2 correct. So how many favorable outcomes is that? That's 1, 2, 3, 4, 5, 6 different ways they could get 2 correct. And how many total outcomes are there here in this chart? Looks like 16 to me. So that would be 6 favorable outcomes divided by 16 total outcomes. That's our step 2 right here. 6 favorable outcomes with exactly 2 correct answers. And the total number of outcomes was 16. So the probability there, we use the formula, is number of favorable outcomes divided by number of total outcomes. 6 over 16, which simplifies to 3 over 8. And you could have converted that to a decimal. You could have converted it to a percentage if you would like. But 3 over 8 is good enough. Let's look at how we would make a tree. So I'll try and keep this here on the screen and scroll down so we could make a tree. So if I was going to make a tree, I'd start on the first question. What are the things we could do? We could get correct, we could get incorrect. Okay, that's the first question. Now the second question should branch off from there. So I could get correct, incorrect, correct, oops, incorrect. That's 2 questions. Gonna scroll down more. Fix this incorrect here real quick. Now on the third question, I could get correct, incorrect, correct, incorrect. So that would be through 3 questions, and I just need to add 1 more row to this diagram in order to get my entire probability space. Let's go ahead and add that last row. If you don't like the tree, you like the chart, you can go ahead and skip this. You don't have to do it one way or the other. Either one works as long as it makes sense to you. See, with the tree, when you get more and more branches, things get a little crowded. It's hard to see everything all at once, because you always got to make a branch off of everything that came before it. So if we look, I could go correct, then maybe I branch down here to incorrect, and then I got correct. Or I could go correct on the first one, incorrect on the second, incorrect on the third, then incorrect again on the fourth. If I follow down the branches, I'll get all my different possible outcomes using this tree. It's another way to do it. Okay, let's go on. Got a little more notes here. The sum of all the probabilities of all the different outcomes in a sample space is always going to be 1. Definitely make sure you got that down. It's right there at the top on this new page. So we know all the probabilities got to add up to 1. All the probabilities together will add up to 100%. We can find the probability of the complement, the complement of an event. The complement is all the outcomes that are not in A. So we want to write that. The complement consists of all the outcomes that are not in A, and it is denoted by A with a bar over it. So if I said, what's the probability you roll a 5 or higher when you roll a single die? So you're like, okay, how could that happen? It could happen if I roll a 5. It could happen if I roll a 6. Now, the complement is everything that makes that false. So if I said, what's the probability you roll a 5 or higher? And I say, what's the complement of rolling a 5 or higher now? You'd say, well, that'd be rolling a 4, a 3, a 2, or a 1. So it's everything that's the opposite, basically, of what you have. So the notation, make sure we got the notation. Make sure you got this A with the bar over it is read as A bar. And then we've got a formula that helps us find the probability of A bar. So down here we've got this formula. The probability of A bar is just 1 minus the probability of A. Head down that formula. All right, let's go on. Oh, good, our sample space is right here for us. 2 6-sided dice are rolled. There are 36 possible outcomes as shown. Find the probability of each event. So this on here, on the right here, this is the sample space. This is everything that could happen. I could roll a 1 first and then a 1 with the next dice. A 1 first, then a 2 with the next die. A 1 first, then a 3. So these are all of the outcomes. This is what a sample space looks like. So let's find the probability that the sum is not 6. So this is one of those that we can use the complement on. Since the sum is not 6, well, that's the complement of just saying the sum is 6. Let's find the probability that the sum is 6. Where are ones here that have the sum is 6? Let's circle those ones that have the sum equals 6. That one, 1 and 5, 2 and 4, 3 and 3, 4 and 2, 5 and 1. All of those have a probability of 6. So that's how many favorable outcomes for a probability of, or for a sum of 6? 1, 2, 3, 4, 5. Out of how many possible here? If you count them up, this is a 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. A 6 by 6 grid. So that means there's 36 outcomes here. So it's 1, 2, 3, 4, 5 out of 36 times 5 out of 36. We get a sum of 6. So the probability that the sum is not 6 is 1 minus the probability that the sum is 6. That's using that complement here. So we do 1 minus that 5 over 36, which gets us 31 over 36. That's how we can find the probability of a complement. So it's a lot easier. We didn't have to count up every one that had a sum of not 6. We just had to count the ones that were 6 and then subtract. Okay, next one here. Probability that the sum is less than or equal to 9. Less than or equal to 9. We could do a complement again. Think about what we would have to do the complement to. So we want to get the sum is less than or equal to 9. So if we count the ones where the sum is 10, 11, or 12, then we can subtract that away from 1 and we should be good to go. So that one's 12, 11, 10, 10, 11, 10. So there we go. We have 1, 2, 3, 4, 5, 6 ways that we could get a sum of 10 or higher. So we can do the complement of that. So to get the probability the sum is less than or equal to 9, well, let's do the complement of the probability the sum is greater than 9. So once again, here we had 6 ways that we could get a sum greater than 9. So we do 1 minus that 6 over 36, which you can see right here, gives us 30 over 36. That would simplify down to 5 over 6, which would be about 0.833. So this is how we can use the complement. All right, let's move on. There's one last you try section, then we are done with our notes. So in this you try section, let me tell you the first one here. You're going to want to, there's no complement in the first one. It's just making a chart, figuring out what your favorable outcomes are, finding those in the chart, finding the total possible outcomes, and doing the favorable outcomes divided by the total outcomes. If you can do that, you can do this you try right here. And I think you can do it. And then down here in the bottom, it's just using the formula to find the probability of A bar. So if you flip back, actually it's at the top of your page right now. If you look at the top of your page and just use your formula 4 times, these ones should be nice and easy. So go ahead, pause the video now. See if you can do these. All right, we are back. Let's go through these together. So the probability, when you flip a coin, then roll a die, that you get tails and then 4. Well, if you put out all of your different possibilities, there's only one time you can get tails and then get 4. Because you have to flip tails the first time and then you have to roll exactly 4. There's not a second way you can make that happen. So there was only one favorable outcome there. And out of 12 total possible outcomes. I'm going to make a chart. I like these charts. Flip a coin, heads or tails. Then we roll a die. So that could be 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6. How many ways, if I went from the top to the bottom, could I get a tails then a 4? Well, I'd have to go tails. And then from here, I'd have to go 4. There's only one way. And how many different total branches are there? There's heads then 1, heads then 2, heads then 3, heads then 4. If I counted up all of these different things that could happen, I get 12 different things could happen. So there's one favorable, that was tails, then 4, out of 12 total things that could happen. Awesome. Let's look at the next ones. 0.55, 3/4, 0, and 0.97. Just to real quickly make sure we understand this, let's look at one together. So the probability of A bar is 1 minus the probability of A. So I'm just going to do this number 4 right here. I'm just going to plug right in what I know. I know that the probability of A is 0.45. So the probability of A bar is 1 minus, I plug in the 0.45 for the probability of A. And I get the probability of A bar is just 0.55. All right, fantastic. Fantastic. Now that you're done with the notes, go ahead, remember, go to the discussion posts there on Canvas, answer those 2 discussion questions, and then finish up your assignment on bigideasmath.com. I hope you've enjoyed your long weekend, your e-learning. I hope you've had a good time. I will see you all on Monday.